Okay, everybody, just making sure. Still not showing up. Here we go. Great. So, not gonna do too much today because I have a busy day planned. But I just wanted to get some prints going mostly, and I wanted to conclude on this string fiasco, which we still I haven't touched it since we left off, so it's still, you know, disappointingly loose. And we can still crank this. So we can play around with this a little bit. We could play around with this a little bit too, but I mostly want to, this whole crash cymbal thing is sort of my main rival in this whole project because it's the one thing I really felt like I didn't achieve in the initial video. The guitar's fine, honestly. Like with the filament string, it works fine and it sounds okay. But this is now just me, nitpicking a little bit, trying new things, mostly just experimenting with this new filament. So this isn't as important as getting a crash cymbal. If I can get a proper crash cymbal, that would be so good. I also have some theories about why this string might not be working because it ended up printing in 2 layers. And so my theory is that the splitting that's happening is happening between the 2 layers, but I don't know actually. Now that I'm thinking about it, that doesn't really make sense because like it's holding together. But we're almost, you know what I mean? We're almost at a full strand, like all these bumpy bits. That's how thick the string used to be, and then this is perfectly smooth, these parts here. So it does seem like if I just keep doing this, I could potentially get to a point where all of these little bumpy bits go away and we're left with a nice tight little single strand. Oh, let me just let the cat in quickly. Very important. My cat gets what she wants. Okay, except for sitting on my lap right now. I gotta keep winding this dust. See, now we're actually getting to a point where it kind of is maintaining tension. Now the issue now is that it sounds bad. It sounds really bad. There's like a lot of random frequencies in here. So, yeah, I mean, maybe I'll just kind of we're kind of getting somewhere with this. Maybe I'll just kind of do this in between the designing of the cymbal and then that way I'm not just like wasting time. I mean, we're getting somewhere. Listen to that. This is kind of cool. It's not going to be, steel string guitar level, but if this works, this process sucks though. But if this works, that'll be just another sort of impossible tone achieved via plastic, which I love. Not impossible. Obviously none of this is impossible. None of this is even that groundbreaking. It's just fun. Okay, wait, let's just keep going. We might be there. And it's sounding better now because those little nodules make the tone sound worse because it makes the string not vibrate uniformly, which is exactly what you want in a stringed instrument is uniform thickness throughout so it vibrates or resonates uniformly and not randomly. And that's what we're getting with this. This is wild. It's like thinner than dental floss. It's crazy that this is filament. We're like 90%, and it's getting higher. I have a feeling it's just gonna break once all of these little bits disappear. Look at this. We're almost there. It's just those little bumps there, that big bump right there, or that big section. That's it though. This side is like, oh, there's a little bit right at the bridge there. All right, let's just take this home. Let's take this home. I want to get this across the finish line so we can move on officially. Whether or not this works, we will move on. This is getting like high. Hi. It's getting high. Hi. That's how I say hi to cats. Hi. It's weird. You could see them like disappear basically. What is happening here? If somebody can explain this, that would be cool. Where is this material going? I mean, a lot of it does get wound up in here. We're almost there. All we need for it to do is maintain a pitch, because this is sounding really good now. Like, now this big bump's about to go over the nut. So you can see there. This is like the last significant bump, and it's about to go right over the nut here. Okay. We're down to our last two tiny little bumps. This one right there. Focus. This one right there. One right there. The rest of the string is clean. This is crazy that this happened. Okay, bumps are gone. Now it's still think there's any way this is going to be able to maintain a pitch. The fact that this is still not breaking is crazy. It just can't maintain a pitch. It just keeps stretching. It is getting better. It almost sounds like a mandolin. Is that right? Ooh, I would love to get some of that kind of stuff in the song just for fun. No. Anyways, let's put this aside. Let's let this string settle. Maybe that's gonna be okay. And instead, I mean, that's crazy. It is staying tight now. Is it staying totally tight? Sounds pretty good.
I'm an imposter, but I don't know who I'm supposed to be.
Like, I don't know what the part would be.
I'm an imposter, but I don't know who I'm supposed to be. I'm honestly under the influence of all I see, and I poke my head into the doors. I make sure to keep one foot from entering, and I keep on starting over once I get cursory knowledge of anything. I'm an imposter. I should have mastered 4 to 5 useful skills by now. 10,000 hours is too much for me.
Anyways, it's just silly. It's Well, I mean, it's cool. I like. It's crazy that that did that. Okay. So I just wanted to jump back to the cymbal because I'm gonna try two more things. I'm going to try. This worked pretty good. I like what happened here. Um, but I really think I want to try just a plain cymbal, and I want to do it with. How do we want to do this? Okay, let's just boys Zelex copy. Keep the bell. I liked how the bell felt. And what do we have for the thickness of this? 3.2 mils. That's not bad. Yeah, that's not bad. Let's just stick with that. I mean, you know what? Let's go big or go home, right? Let's bump this up. Let's bump our numbers up a little bit. Let's go up by 1. So now we got a real fat bell, and that's an issue as well. Boom. Don't know when that happened. Okay. Is there like a weird... I can't tell. Maybe I need to turn the opacity down on this. Feeling really weird yesterday, and I'm feeling better today, but still not amazing. So apologies if I seem a little off. I'm not sick or anything. I think it could be a weather thing. There's like a lot of pressure or something. I don't know. Okay, so I'm just adding some fillets to try and sort of literally round out the sound a bit. I can go up all the way. Yeah, okay. That's nice. That's nice. And then we are going to do this instead. We are going to construct an axis through a cylinder. Boom. Okay. We are going to construct a plane at an angle. That's the edge. Let's do it that angle. Okay. And then we are going to skizzetch. And then, what do I want to know about this skizzetch? Well, I know a few things about this skizzetch. What is the diameter of this Cymbi? 304.8. Seems arbitrary. Let's do 310. Let's go 310. So we go to the middle here and 155, right? Seems small. I guess that's right. And then, theoretically, just a straight line, I think. Oh, wait, we don't want to go to 0. We want to make sure there's still some thickness on the edge here, so we'll go up 0.4 millis. Do I want to kind of like maybe swoop it a little bit? Let's think about that, right? So instead of just doing a straight line like that, I am thinking if I added a little bit of oh oh that's a lot. This will leave us with more. You know, so it's like got a bit of a scoop there. Now, I want to try some stuff with this because basically I think this will sound interesting on its own, but it's not the full goal. This Prince flat, I think it's gonna do the like taco Pringles thing. Oh my god, I haven't been showing this. I suck at this. I suck at this. Okay. Um, so all I've done is I made the bell a little bit thicker. So the actual, you can see here, this was the original bell thickness. I think it was only 2 mils. This one's like 7 mils or something. And then we just did a flat thing, a flat disc, but it tapers, and instead of just a straight line between these two, it has a slight little curve to it, and that is to hopefully encourage more of the thinner part to create more sound than the bell section. So what the plan is, we are going to print this, and we're going to try it as soon as we pull it off the plate. And my assumption is, as soon as we pull this off the plate, it's going to do that thing, like all of the other cymbals have done. But we'll still see if it works. We'll see what happens. I want to stick to printing these cymbals flat on the build plate. Theoretically, if I added a curve underneath like this, we would get some really nice internal stresses that would help with the cymbal tone. But printing a upside down bowl like that at that angle would require support material underneath the entire thing. And I haven't had time to play around with support material with PPSCF. I think I did a couple prints that needed supports and they weren't that easy to take off. So I want to try and avoid that. But the other thing I wanted to try is annealing is something that supposedly will help a PPSCF part sound even higher pitched. It'll make it more brittle, but it might make it sound better. I don't have an oven, a regular oven that I want to use that's big enough for this. So like I'm not going to put this in my food oven, the one in my kitchen. I do have a little toaster oven, so I was going to try and maybe anneal the tuning fork and the tines on the marimba to see what happens there. But what I do have is some bricks and the capability to make a fire. So I was thinking about making basically a pizza oven for this, and it's not going to be accurate at all to the temperature, but I was thinking what I could do is I could sit this on kind of a mold and actually let it go way above the annealing temperature and see if it actually kind of deforms into that sort of typical cymbal shape. It droops, I'm aiming for a bit of a droop. That might totally mess up the crystalline structure in there and like make it sound worse, but I want to try it. So this is cymbal test number 1. The second thing is, remember we were working on this. I was going to try and make a rain stick, and this is my like backup that I know is going to work to some extent. But I couldn't figure out how to design it, and it occurred to me it's actually like I was making it so much more complicated than I needed to. Because I needed, well, let's just start designing it, right? let's just start designing it, and then we can talk about it as we design here. Okay, wait, actually, I'm just going to get some wood on the fire, and then we'll be good to go for the next little bit. Okay. So, basically what I want to try and design is a super, super small spiral staircase. And I want to do it like maybe 100 millimeters in diams. And so, say I wanted this to be a cylinder that's like 300 millimeters tall. Basically, I want a bunch of sticks that run across the cylinder, going all the way up the cylinder. But I don't want them to be in the same spot. I want them to be either randomly placed within that cylinder or a nice, smooth spiral staircase. I'm kind of thinking the spiral staircase is going to be. Oh, I keep getting hair in my mouth. The spiral staircase thing is going to give us the most like consistent sizzle. So, I was trying to use like actual settings on here to just generate it, but it didn't. I just couldn't get it. Like using a coil, using a spiral, that kind of stuff. Couldn't figure it out. I think I figured it out. In order to make this really high pitched, I think I need it pretty thick. Like 3 mils, probably. And then all we need is a little staircase. And, originally I wanted it to be like super tiny. But I think since we're doing a staircase, we could actually afford to make it a little bit bigger. So, like, we can maybe go with. I'm just going to go kind of in between. Let's go with like a 2 millimeter wide little guy. Right? Stick with me here. And I'm just going to get rid of all these boys. And I'll even get rid of that. So, this is all one homogeneous piece. So the issue is there's going to be thousands of these going up. And I didn't want to have to rotate each one. But I don't have to rotate each one. I can use I'll show you. I'll show you. Like, I don't know why I didn't think of this. So let's extrude this. Let's say we want this to be 1 millimeter. If we do it 1 millimeter, then we only need 300 of these, which is actually totally doable. So let's do that. And then we're going to move this. We're going to create copy. Oh, I'm actually going to grab it. So we grab it in the center. Can I grab it right? Yeah. And then we're going to move this. We're going to create copy. We're going to move it up 1 mil. Boom. And rotate it. That much. So the reason this is great is because, 2.7 degrees. So let's remember that. The reason this is great is because, I was a little bit concerned about the bridging. I think the printer could handle bridging like this. But the fact that we're doing a staircase, it's actually only bridging right here because this part's going to be pretty well supported by the one underneath. But here's where it was so stupid. Now I can go, this is one body. Oh, wait, it's not one body. So I'll combine these two. Doop. Combine. Boom. This is one body now. So now when I move this, it's one body. And I move it up. Oh. hate the movement tool because, yeah, so I can grab it there, create copy, move it up. This time I'm moving it up 2 mils, and I'm going to rotate it, I guess 2.7 times 2, right? And then we combine these again. Doop, doop. Now, I realize I have to multiply the, so 5.4 was the last one. So let's move this again, copy, and we're going to move it up 4 millimeters this time. And we're going to rotate it 5.4. Oh, no. We're going to rotate it 10.8. Oh, yes. See this? This is nice. Let's combine these. Boom. Right? So every time I'm doubling how much I can do at a time. So simple. I don't know, like, I mean, it's still labor intensive, but not that bad. The movement tool is pretty clunky, so I want to move it up 8 this time. And what was it? It was it? See, I forgot. It was 10.8. 10.8, and I can just go times 2. Right? Can't I? Can't I do that? Nope, apparently not. Okay, I just have to do the math in my head, which is embarrassing for me to do because I fucking suck at math. Especially right now. Now I'm under pressure. 8. So that would be 10.8 times 2. 21.6, right? Look at that! It's looking great! It's looking great. So I just got to make sure every time I grab it, I'm grabbing it in the center, creating copy, moving it up. So 16. Oh my god, I already forgot the number. It was 20. Is that what was it? Oh my god, I'm so dumb today. It's 21 point. Okay, so 5.4, 10.8, 21.6. Don't laugh at me. Don't laugh at me. I'm not having a good day. Mathematically. 21.6 times 2. Okay, this is actually way better because now I can just keep this on here. 43.2. Yes. Oh, look how pretty that is. What did I just do? 16, so 32 this time? And then 43.2 times 2 is 86.4. Oh, this is actually so nice because now I don't have to remember this. Oh, yes. Look at that. Okay. 64. Yes. And then we times that by 2. 172.8. Boom. Look at that. I think that's going to create some really interesting sounds. Move. Create copy. $128, right? Yeah. Oh, shit. Ah, the moving tool's so clunky on this. $345. Oh no. Does that work? I can't see it anymore. So, oh yeah. Oh yeah. How tall are we now? God, that was pretty embarrassing, guys. 256. Let's stick with 256. Oh, and then I want to do a chamber. So we can combine these. Choop, choop. Okay. And then I was thinking about just going straight up so that I could have a chamber. Do we want to split the chamber? Let's just go 40 mils. Now, do we like the split chamber? This is going to be two definitive sides, right? This is weird to look at. Do I want two individual chambers, or do I want this to be... I think we could just do that, right? And then we'll fill this. We'll print a cap. Actually, I'll just make a cap right now. Let's go just 20 mils. I don't know what this wants me to do. New body, I guess. And then we can hide that. Extrude this up 2 mils. Oh, let's do 3 because everything's 3 mils. Okay. Hide our sketch. Nice. That's a lid. Real simple. That's our tube. Okay, so that's what we're going to do. We're going to print both of these. So this is going to be called standard cymbal design. This will be called the rain stick tower. And this will be called the rain stick cap. And I'm going to have to print a bunch of little beads that go in there, which is fine. So let's see. Let's save this. Nice. Okay. Let's open up our studio. Let's load in our standard cymbal design. And we're going to have to move it over there. Zoom. Slice this. 6 hours and 53 minutes. Is this totally solid? I think there's one section of not solidness. Yeah, right there. Yeah, so let's make these 9 wall loops. Slice. Sliche. 162 grams. This is quite the print for this. So I might do this overnight, right? So let me save this. Cymbal design. It'd be so funny if this ended up being the best, because this is just what, like I should have just done this from the beginning. This is just what a cymbal looks like. But we'll see. Let's see what happens with this. Ooh, 18 hours, 448 grams. I did not expect this to be that intense. I thought this was going to be... Oh, that feels kind of wrong. That feels kind of wrong, but you know, I guess the numbers don't lie. That is a crazy, that was a heavy print. I have quite a bit of filament, but I don't feel like this should be that crazy. I'm gonna... Oh, God. What can I do? If I go back to the beginning of this. Maybe I make this... Maybe I'll make the walls smaller. Wow. One 1.5. Yeah, let's do 1.5. That'll literally cut it in half. Um, So that's 2 mils. I make that 0.75. So now if I finish this sketch and I pull this timeline over, does it update my design? Looks good still. These are less supported now, but let's try it. Does this cap still fit? Inspect. It should, because I referenced it. 103 millimeters diameter versus 103 millimeters diameter. Okay, so thinner. Thinner. What are we looking at here, folks? That's more realistic, I think. I think that's more realistic. Why? Okay. But that's 10 hours and 58 minutes. Should we print that today? Because I will be able to monitor this one a little bit. Let's try it, because I'll be able to watch it, and then if it doesn't work, then we're good. I'm gonna not print the cap right now, because it doesn't need to be printed. And then let's just put this. I don't know why you wouldn't just go right in the center. I don't know how to just center it right on the build plate. That would be nice, wouldn't it? Okay. And maybe I could print. I'll probably print the cap out of something else, to be honest, because I actually don't know if the clearance between this material's got a rougher surface than PLA. So, okay, let's print this guy. 8 hours 43 minutes. So yeah, I can print it, and I'll have all day to monitor it. Let's do it. So, I didn't sleep very good last night. Okay, printer is starting up. So that pretty much gets us, hopefully, a cymbal sound that we can actually use. I want a bit more in this song, but I think we're getting pretty close to the end. Just kind of thinking about instrumentation. I would like something a little more like high frequency. Everything's kind of mid to low, even with the PPSCF. You know, I might print a flute or something. Might print a flute just to get us across the finish line. So, anyways, I'm gonna think about that. I'm gonna monitor this print. I'll let you know how it goes. But until then, I will see you in the next stream.